All right, today we're going to dive into a really fascinating theory. It takes a government missile test and uses it to look at one of the most seen events in modern history through a completely different lens. It's all about physics, really. It poses a simple but powerful question. How could something made of lightweight aluminum seemingly cut right through solid steel? Let's take a look.
And this is really the core question, isn't it? The whole argument we're examining is built on this idea that a controlled scientific experiment could be used as a baseline, a kind of physical reality check for what we see in historical footage.
So, where does this analysis even begin? Well, it starts by pointing out what it calls a fundamental contradiction in the materials themselves. You've got a commercial airliner, right? Engineered to be as light as possible, made from aluminum. And on the other side, you've got a skyscraper built around a core of massive, heavy-duty steel columns.
We've all seen the images. Visually, it looks like the plane just slips right in. But the source material asks us to pause for a second, take off our history hats, and put on our physicist hats. Look at it as a pure physics problem. How does a mostly hollow object made of a relatively soft metal penetrate a super dense, super hard structure like that? That right there, that's the visual paradox we're going to unpack.
To try and solve this paradox, the analysis points to one key piece of evidence, and it comes from a pretty official source, a high-speed impact test run by Sandia National Laboratories, which is a major research and development lab for the US government.
So here's the quick rundown on that experiment. It happened back on December 9th, 2015, but look at the objective there on the slide. This is really important. The test was designed to check the accuracy of a missile hitting a target, not to see how much damage it could do. That little detail is absolutely crucial for the comparison this theory is about to make.
Okay, let's break down the test itself. The projectile wasn't some hollow tube, it was a solid metal missile. It was moving at about 470 kilometers per hour. And this is key, it had no warhead, no explosives. This was all about pure kinetic impact. The only force involved was from the collision itself, nothing else.
And here it is. This is the result from that test that this entire argument hinges on. Even though it was a solid piece of metal, only about a quarter of the missile actually made it through the target. The rest of it just completely shattered on impact. And that forms the basis of the whole question. If a dense, solid object designed for impact fails like this, what should we really expect from a hollow one?
And that question brings us right to the heart of the physics here, the massive difference between the two materials we're talking about, the aircraft's aluminum and the tower's steel.
This slide really lays out the mismatch. According to the source's numbers, the aluminum used in planes has only about 57% of the hardness of the structural steel in those towers. So you've got a hollow structure designed to be light versus solid columns designed for incredible strength. According to this analysis, it's not a fair fight at all.
To make this idea really stick, the source uses a simple analogy that I think we can all picture perfectly. It says an airplane hitting a steel frame building is like a small car rear-ending a huge truck. We all know what happens, right? The car, because it's the softer, lighter object, is the thing that just crumples.
So we've talked about the materials. Now let's get into the specifics of the structures themselves. The analysis paints this picture of the tower's outer wall as being like a giant, incredibly strong steel sieve.
Now, before we see that sieve, we got to get one key physics principle down: shear force. The easiest way to think about it is as a cutting or a tearing force. If you have a long object, like an airplane, hitting a fixed wall, the shear force right at that point of impact is absolutely immense. It basically wants to slice that object clean in two. And this slide puts some numbers to that sieve idea. The source points out that the windows were only about 73 centimeters wide, and between them were these massive vertical steel columns. It creates this incredibly dense grid. Now think about this. The front section of the plane, from its nose to its wings, was 19 meters long. That whole length would have had to punch its way through this really tight, really strong steel mesh.
And this is the critical point. That entire 19-meter front part of the plane, it's mostly hollow. And importantly, it has no fuel tanks. So according to this theory, as soon as that section hits the steel grid, all of that immense shear force would be focused right there, leading to a total structural failure at the point of impact.
So let's put all these pieces together now. We've got the missile test data, the science of the materials, and the analysis of the structures. With all that, the source proposes a totally different sequence of events, what it argues should have happened based on these laws of physics.
Okay, let's walk through it.
Step 1, the plane's nose hits that steel grid. Step 2, because aluminum is so much softer, the hollow body can't break through. Instead, it starts to crumple up from the outside in, just like that car hitting the truck. Step 3, those shear forces become overwhelming, and they just tear the wings and the fuselage apart. And the result? The entire event happens outside the building, with the bulk of the plane and debris falling to the ground.
And this brings us to the really big consequence of that theory, the fuel. You see, commercial jets carry almost all their fuel in the wings, not in the main body. So if the plane shatters on the outside of the building, then the wings and all that jet fuel would never make it inside to start those fires. In this scenario, the fires, the debris, the whole event would have happened down on the street.
And so this is where the analysis leaves us. It's a pretty challenging thought. We've just walked through an argument that uses a government experiment and basic principles of physics to suggest that what we all saw on the footage might just contradict what the laws of physics would predict. And that leaves us with a really tough question, doesn't it? When what we see with our own eyes and what a physics-based analysis tells us seem to be in direct conflict, what are the right questions we should be asking?